I am Arpit, and now I am here with the Yojana analysis for the month of December 2023. As we cover every month, this monthly magazine Yojana, we are here with the December edition. In this, we will be covering 6 topics, and the entire magazine will be covered in 3 parts or 3 videos, you can say. This is the first video where the topics covered are India's moonshot. Actually, the topic is titled like this only in the magazine, but yes, it talks about the entire space program of India. So, we will be seeing in this topic various, uh, programs launched by ISRO, like Mars Orbiter mission or Chandrayaan missions or the Astrosat missions. Apart from it, we will also see the technological capabilities of ISRO, the launch vehicles available with ISRO. All these things we will be covering in this topic. The second is regional rapid transit system. India has got its first regional rapid transit system. Actually, the entire length of this regional rapid transit system is going to be from Meerut in UP to Delhi, that is still Sarai Kale Khan. But a section of this regional rapid transit system has been opened, and this is basically connecting Sahibabad and Duhai. Sahibabad is in Ghaziabad. So we will look into this, that what are the details of this particular, transit system or new transportation system which we've got, and the sources of funding for this particular project. The second part will be covering India's growing stature, a rising superpower. It is all about, how in the world India's stature has been growing as a country, how all the countries in the world, whether developing, underdeveloped, or developed for that matter, are looking towards India for solutions to the ongoing problems the world is facing. So we will look into that in this particular topic, or in this particular part of Yojana, that is the second part. And Meri Mati Mera Desh. This was a campaign run by the government of India where people from all across the country, they were required to gather, soil, mati from their particular villages and some rice grains. Those, you know, uh, soil or rice grains were collected at the village level or at the town level, and they went to the state capital. From the state capital, they've come to the, national capital, that is Delhi. And here, a Vatika and a Smarak is going to be built. What does the government wanted to signify with this particular campaign? The government wanted to simply signify one, aspect, that is Ek Bharat Shresht Bharat. And obviously, this particular campaign was, paying homage to our freedom fighters who have lost their lives or who have contributed in any way for getting this country formed. So this was a campaign. The third part of Yojana, we will be covering India's industry sector, where various, industries we will be covering. This industrial sector is very, very important and a key driver to employment generation in the country. It is currently the second biggest contributor in the GDP. The first contributor is the service sector, but yes, the industries in India, they are now picking up, especially after the Make in India launch program. So we will look into the details. And finally, we have something from the primary sector, that is agricultural and rural development. We will look into this aspect as well. So these are going to be the 6 topics which we are going to cover for, the December month from the magazine Yojana. This will be covered in 3 parts. Part 1, we will be covering these 2 topics. Part 2 and Part 3 videos, will be followed by this. So here in Part 1, these 2 topics are going to be covered. So let's get started with the first topic. Now, India's space program, it picked up momentum in the mid 1960s. The main aim of launching India's program was, socio-economic impact of that program. The development, I would say, scenario at that time was not, I would say, so great. India was among the underdeveloped countries of the world, and an underdeveloped country picking up a space program was something which was unique. But we were very clear in our, I would say, objectives of our space program, that we wanted to impact, the socio-economic domain from our space program. So, the Indian space program was developed for scientific research and applications in the 1960s, mid 1960s, I would say. There was an emphasis on societal benefits and self sufficiency. Now, UPSC has also asked a similar kind of question in mains 2016. List down the various programs of ISRO this year. That was the first part of the question. This question was asked in GS3. What are the socio-economic implications of these programs? So whenever you study about any programs by ISRO or any, I would say, space program, you should also look into other aspects, not only the scientific or technical aspects, because that is where the questions will be framed from. And that is one of the objectives also of our space program. Many important technologies, materials, and industrial processes have been developed by Indian scientists who have made extensive use of in-house and external resources. So, if I say that the Indian space program is completely indigenous, no, I would be wrong. Indian space program, we have developed self-reliance in designing and manufacturing launch vehicles and satellites. Their complete self-reliance is there, but there is an area which is lacking, where we need to import the products. This area is the electronics for launch vehicle, avionics, and satellites. So this electronics part, or the components, electronic components used in these, I would say, space objects are imported. We are still, relying on other countries for these objects. The National Space Policy, which was launched in 2023 itself, talks about bringing more and more self-reliance. So we will see in the times to come more and more startups in this domain. Now, the launch vehicles. These are one of the major components of our space program, because these are these vehicles on which the satellites are mounted and they are launched. The rockets which we see taking off, those are launch vehicles. So, it is very important if we want to launch multiple satellites or multiple, I would say, programs. We need launch vehicles. Without launch vehicles, they cannot be launched. So, ISRO has developed 4 types of launch vehicles. First is Polar Satellite Launch Vehicle. PSLV it is called as, and it is considered to be the workhorse of ISRO because majority of the satellites are launched by PSLV. Then Geosynchronous Satellite Launch Vehicle, this is called as GSLV, primarily used to launch satellites in the geosynchronous or geostationary orbit, which is 36,000 kilometers above the Earth's surface. Then the third type is an upgradation of GSLV only, that is Geosynchronous Satellite Launch Vehicle Mark 3 or Launch Vehicle Mark 3, LVM3 we know it as. Now the Chandrayaan mission was launched on LVM3 only, Chandrayaan 3. Now a cryogenic engine, the third stage fuel, where this is basically let's suppose this is the launch vehicle. Now there is fuel in this. Now there are various stages of fuel. The stage 1 solid fuel, stage 2 solid fuel, stage 3 is cryogenic fuel. Cryogenic fuels are liquid fuels which are maintained at very low temperatures. These cryogenic fuels help projects to be launched if they are if they have to travel far away. So there this third stage fuel comes into picture. This fuel is highly efficient, which helps or which enables these projects to go far off. So we have this indigenous developed cryogenic engine over here in this Mark 3 LVM3. Then very recently we have started with SSLV, that is Small Satellite Launch Vehicle, for launching small satellites. I would say payload is very, very small. Now earlier what used to happen, these small satellites, even if they are ready, they had to wait for bigger satellites when they will be launched on PSLV or GSLV. And these small satellites were like, piggybacks on these particular, I would say, big projects. So their launch got delayed, but now a small satellite launch vehicle is there for launching specially the small satellites. This is very cost effective. The time taken for launching these kind of satellites and building up this kind of launch vehicle is drastically less, which makes launching more and more efficient. So we will have a look at the differences in all these four launch vehicles as well. PSLV has been a versatile launch vehicle deployed for launching all the three types of payloads. There are three types of payloads. Earth observation payloads. They are generally in the low Earth orbit or polar orbit. Then geostationary. They are 36,000 kilometers above the Earth's surface. They appear to us as stationary because the pace at which the Earth is rotating, they are also rotating at the same pace. That is why they seem stationary to us. That orbit is called as geostationary orbit. Majority of the communication satellites are over here. Navigation satellites, like we have this NAVIC, that is Indian Regional Navigation Satellite System, which is also having 7 satellites in it, and out of 7, 3 satellites are in the geostationary orbit and 4 satellites are in the geosynchronous orbit. So that is also there at 36,000 kilometers above the Earth's surface. So PSLV is instrumental in launching all these three. Don't go with the name Polar Satellite Launch Vehicle. Means it will only launch vehicles in the polar orbit. Polar orbit is comparatively, I would say, at less height, somewhere around 1000 to 1500 kilometers. It is at times referred to as low Earth orbit also. But don't fall into this that on PSLV will only be used to launch vehicles over there only. So, this is something which needs to be understood. GSLV, Geosynchronous Launch Vehicle, is an indigenous cryogenic upper stage, has enabled the launching up to 2-ton class of communication satellite. So this is, weight centric. Up to 2 tons GSLV can launch. But this LVM3 is basically an advanced version of GSLV only, because in the last slide we saw that LVM3 is also known as Geosynchronous Satellite Launch Vehicle Mark III. So it is an updated version of GSLV only. The LVM3 is the next generation launch vehicle capable of launching 4-ton class of communication satellite. Here 2 tons, here 4-ton. Communication satellites generally launched in the geostationary orbits. And 10-ton class of payloads to low Earth orbits. So if the satellite has to be taken to low Earth orbit, means 1000-1200 kilometers, then up to 10 tons it can be taken by LVM3. And if it has to be taken to the geostationary or geosynchronous orbit, then up to 4-ton satellites can be taken. The vehicle was developed with completely indigenized technologies, including the C25 cryo stage, means cryogenic fuel is there in this stage. And now the last launch vehicle, SSLV, the newly inducted small satellite launch vehicle, which was developed in record time to satisfy the requirements of small satellite launch vehicle market. As I told you that these small satellites depended upon the larger satellites. When they will be launched, then these will be attached along with them and launched. There was, excessive delay in their launches earlier, but now with the induction of SSLV, they can be launched timely. Now, over the years, ISRO has become self-reliant, as we've already seen in the first slide, and we will see the technologies which has been developed by ISRO over the years and how these technologies have helped in various programs which have been launched by ISRO. So basically, ISRO was an early developer of cutting edge technologies like sensors, inertial navigation, guidance and control system. This inertial navigation is very, very important, because if we have to launch projects to, I would say, distant places, like for example, we launched a Mars orbiter mission, or we launched Chandrayaan 3 also. There, we used very less fuel. And obviously, Indian space programs are known for cost-effective launches. So, Inertial navigation is we depend upon inertia. Inertia will, navigate that particular, I would say, payload to wherever it is, and whenever needed, some maneuvers are given. So in this, the fuel spent is very less. That is called as inertial navigation. So we've developed this kind of technology at an early stage, only we developed it. The success of extremely important missions like Mars Orbiter mission and Chandrayaan 3 can be attributed in part to this unparalleled capacities which we have developed. Having an in-house optics and optoelectronics expertise has also allowed for creation of a wide range of specialized payloads which are used for Earth observation and planetary exploration. Planetary exploration like Chandrayaan 3, planetary exploration, Mars Orbiter mission, planetary exploration mission it is. ISRO has dedicated groups to research and design satellites and their associated payloads. Satellite systems, including antennas, reflectors, radio frequency systems, are constantly updated to meet and surpass global standards for technical progress. But, these things have been developed by ISRO, but we should not forget that there are some domains, particularly electronics, which are used in all these launch vehicles or satellites which we are importing presently. We have to reduce the import of those materials and become Atmanirbhar in this aspect as well. Now, major areas of application. Now, as I've been telling you that, the space programs, one of the major objective was socio-economic impact. So we'll see in this particular slide that what have been the major areas of application of the Indian space programs. The foundation was laid by National Natural Resource Management System (NNRMS) in the early 1980s for the use of Earth observation data in GIS applications. GIS is, I would say, geoinformatics system at the national level, spanning all potential ministries and departments. The Indian remote sensing program started. Remote sensing is satellites are there, located at remote positions, and from there they are gathering data of or about the Earth. Obviously, about the Earth means India on Earth. About India, they're gathering data from a remote location and then sharing that data with us. What will we do of that data? We can launch various programs or schemes. So this particular program of ISRO has helped us in MG Narega, that is Mahatma Gandhi National Rural Employment Guarantee Act. Let's suppose, any work is being done by the rural laborers under MG Narega. Let's suppose a canal is being built or a road is being constructed. Then satellite images can show the progress of the work done by them, or satellite images can be used for surveys that where can that canal be built or where can that road be built. All these inputs can be given by the satellite, I would say, data shared by satellite communication. Then Pradhan Mantri Gramin Sadak Yojana, Pradhan Mantri Krishi Sinchai Yojana, Amrut, there is Atal Mission for Rejuvenation on Urban Transformation. Basically, it is very much important in the present day world because urbanization in India is increasing at a very fast pace. So there are all these things. Then Pradhan Mantri Fasal Bima Yojana, Swamitva Yojana. Swamit is basically digitalizing land records. And not only digitalizing, but after digitalizing, redistribution of land if it is found that on a single person the land is more than the allocated amount. Then UIDAI, basically Unique Identity Authority of India. All these things, or all these programs of the government which aim to enhance socio-economic development, all these schemes, they use satellite data for their effective delivery or identification of projects. And this is how ISRO is benefiting us socio-economically. Major programs by ISRO. The first is Indian Regional Navigation Satellite System, NAVIC. Now we all use Google Maps in our phones, and Google Maps is based on Geo-Positioning System, that is GPS. GPS is the navigation system developed by USA, and this is the navigation system developed by India. Although it is not so much prevalent, but yes, in the times to come, you will see applications in your mobile phones, just like Google Maps. The navigation in those mobile phones or in on those applications will be from the Indian Regional Navigation Satellite Systems or NAVIC. NAVIC stands for Navigation with Indian Constellation. Indian constellation of 7 satellites. There was a question in this year's prelims as well with respect to NAVIC. Now, GPS basically is covering the entire globe, but NAVIC is only covering 1500 kilometers around India and the entire India. So, this is basically one such different. Second difference is GPS is having 24 satellites, a constellation of 24 satellites. We are having constellation of only 7 satellites. Obviously, our geographical reach is less. GPS geographical reach is entire globe. Now I am comparing it with GPS only. Does America and India only have navigation systems? No. China has its own. Russia has its own. European Union has its own. Japan has its own. These are the countries which have their own navigation systems. But yes, the most widely used navigation system is GPS. So this is there. It provides accurate real-time positioning. I'm now talking about NAVIC and timing services over India and the region, extending approximately 1500 kilometers around the Indian mainland. The variety of services offered by NAVIC aid in different applications like vehicle tracking and fleet management. Actually, there are two usages of this NAVIC. One is the military use or strategic use, and the other is the civilian use. We, the people, can use it in our phones. Various, I would say, companies, startups can use it. Like Zomato uses it, or online delivery companies like Flipkart or Amazon uses it. E-commerce companies. Many companies do use it where deliveries are a big, I would say, component of their business. So everywhere, this can be used. Then apart from it, in disaster management, this can be used. Vehicle tracking and fleet management for the military largely. Location-based services integrated into mobile phones, we the people. Terrestrial navigation aid for travelers. Time dissemination. Disaster management, for disaster management also it can be used, including services to our strategic users. Strategic users are the military personnel or the security forces personnel. The next is AstroSat. It was India's first space observatory. A question about this was asked in 2016 because it was launched in 2015, September 28, 2015, with a lift off mass of 1515 kg by a PSLV C-30 rocket from Satish Dhawan Space Center, Sriharikota. Now, achievements of AstroSat, that is a space observatory of India. Almost 2,000 people from 54 different countries have signed up to use AstroSat data. In September 2022, more than 275 pieces for academic journals and about 500 pieces for GCN Circular, this is a space circular, and Astronomers Telegram and conference papers were published using AstroSat data. So the data which is gathered by AstroSat is being used not only by people in India, but people all across the world. This is definitely extending our soft power and demonstrating our space capabilities. Next is Mars Orbiter mission. This mission, launched in 2018, was traveling to Mars and it had to orbit Mars. No landing was there. And after 300 days of traveling between the planets, it was placed in an orbit around Mars on 24 September 2014. So, 2014 successfully placed, 2013 it was launched. Now, over the course of its 8-year lifetime, the mission, which carried a total of 5 scientific payloads, made major contributions to our understanding of Martian atmosphere, exosphere, surface features, and so on. So, a lot of data was gathered by this Mars Orbiter mission. Remember, NASA launched a lander mission on Mars. The Perseverance rover was roving around Mars. And in and around the same time only, we launched Mars Orbiter mission, where our orbiter was orbiting around Mars. Now, NASA and ISRO both have collaborated on this front also. They are sharing data with each other, which will make both these programs a success. The Mars orbiter mission lost touch with Earth in April 2022 because of a protracted eclipse which happened on Mars. Actually, the duration of this particular mission was also 8 years, and 8 years were completed in 2022. And after spending nearly 8 years in Martian orbit and accomplishing a wide range of scientific goals on Mars and the solar corona, this is now non-functional. Now, the very important Chandrayaan, because 2023, a lot about Chandrayaan 3 has been spoken because of its success. But, we should not only look to Chandrayaan 3, we should look to Chandrayaan 1, 2, and 3. Then we will, get to know the entire scenario. Chandrayaan 1 as a program was launched in 2008, 22nd July 2008. The main aim of Chandrayaan 1 was to orbit around Moon. An orbiter was sent and it had to orbit 100 kilometers from the surface of the Moon. That orbiter was placed in the Moon. Chandrayaan 1 was success. So this is, let's suppose, the Moon. The orbiter had to be placed some 100 kilometers above the surface of Moon. This was Chandrayaan 1. Chandrayaan 2, it was successfully launched on the same date, that is 22nd July only, in 2019. Now, orbiter was already there, but Chandrayaan 2 actually wanted to go one step ahead. Now in Chandrayaan 2, there was an orbiter, a lander. Inside the lander was a rover. The mission was partially successful, I would say, because the orbiter was placed in the orbit where it was intended to, but we failed to do the soft landing. And this is what we accomplished in Chandrayaan 3. Chandrayaan 3 mission set out to prove that soft landing and roving capabilities could be accomplished on the Moon. India became the first country to do soft landing on the south pole of Moon. So that is what the success of Chandrayaan 3 was. Because we failed in doing soft landing over here, we accomplished soft landing over here. Chandrayaan 3 did not have an orbiter because the orbiter of Chandrayaan 2 was already orbiting and is still orbiting. In fact, the lander of Chandrayaan 3 established contact with the orbiter of Chandrayaan 2, which aided the lander of Chandrayaan 3 in landing. This is what the orbiter of Chandrayaan 2 had to do with soft landing in Chandrayaan 2 only. But since soft landing failed, it kept on orbiting. It is still orbiting. The orbiter of Chandrayaan 2, it established contact with the lander of Chandrayaan 3 and it helped this in landing. Then, just after, I would say, the success of Chandrayaan 3, the Aditya L1 mission was also launched. This Aditya L1 mission is a mission by ISRO to study the sun's surface. Obviously, it cannot go and land on the sun, so it will be placed on a point. That point is called as Lagrange point 1, L1. That is what L1 here signifies. This is the first in India to focus only on solar science. When the spacecraft reaches a distance of around 1.5 million kilometers from Earth, it will enter a halo orbit around Lagrange point 1. Now, what is this halo orbit? This halo orbit is to ensure that its observations of the sun are unaffected by occultation or eclipse. In addition, this will make it possible to track the effects of solar activity on space weather in real time. So, let's suppose this is the sun, this is the Earth. Lagrange point is somewhere over here. This is, I would say, 1.5 million kilometers from the Earth's surface. So this L1 will be here and it will be, taking the observation of the sun and, giving various, I would say, findings with respect to activities happening over there. Now the upcoming programs of ISRO, we should know these as well. The Gaganyaan mission, which is going to be a manned mission in the low Earth orbit, which we will see getting launched probably in 2024 or 2025. As per ISRO, by 2024, we can see this. The next is NASA ISRO Synthetic Aperture Radar. You know, aperture stands for apparent temperature. So this is going to study the Earth's atmosphere, probably the impact of global warming because the temperatures are rising globally. That it is going to study. ExpoSat mission. This mission is also going to be very much important in space exploration. I would say future space explorations. And last is the Bharat Space Station. It is going to be an observatory of India in space. Probably the Prime Minister has given this mission to ISRO, and by 2035-36 this mission has to be accomplished by ISRO. This is what the target year for this particular mission has been set. So we may see our own space station just like Chinese have, or there's this international space station which is, I would say, a collaboration of 5 countries or 5 space agencies. So this we will have our own space station in the time to come. Apart from it, Chandrayaan 4 can also be there, which can be, I would say, a sample bring back mission. Chandrayaan 5 can be there, which can be a manned mission to moon. These things definitely can be there. Now the second topic is regional rapid transit system. Now this was in news because India got its first regional rapid transit system. It is basically connecting Meerut to Delhi. Actually, when this rapid transit system was being proposed, so there was some talks that Panipat to Delhi should be there. But after careful assessment, we saw that the number of people who commute between Meerut and Delhi, they are, I would say, way more than the number of people who commute from Panipat to Delhi. And hence, Meerut to Delhi became this, I would say, first regional rapid transit system. Now, the inauguration was done, but we need to understand that Sahibabad to Duhai Depot, this is basically a sub part of this Meerut to Delhi entire, I would say this is up to 82 kilometers, but this is a very small portion which has been inaugurated and the trains have been running on this. Total cost 30,274 crore, $3.8 billion. Entire corridor operational by 2025. Transit type semi-high speed. The operational speed is of 160 kilometers per hour. Average speed will be somewhere around 100-110 kilometers per hour. So that is why rapid transit, the speeds are high. Now here we can look to the entire route. There is basically Meerut South. This is Modipuram Depot. This is entire Meerut, because it will not only go to one station in Meerut, things will develop in Meerut as well. And from there, it is coming to Jangpura here in Delhi. But majorly, it will be here till Sarai Kale Khan. This is the entire length. The portion which has been opened is this portion. Now open, which you are seeing, Saibabad to Duhai Depot. This portion has been operational. So, this is basically what the entire regional rapid transit system is. Now, we need to understand this also because, UPSC can be tricky and asking questions in prelims with respect to this, the sources of funding. Multilateral funding, $1 billion from Asian Development Bank. It is a multilateral development bank in Asia, headquartered in Manila, Philippines. $500 million from New Development Bank. This is basically the Bank of BRICS. $500 million from Asian Infrastructure Investment Bank. This is basically headquartered in China. India is a contributor to this bank as well as this bank. The main thing which we need to note over here is that the conventional sources of funding from multilateral banks like the World Bank have not been taken. This clearly highlights the shifting course of funding, because it is widely believed that the funding from multilateral institutions like the World Bank, those fundings, first of all, are difficult. Second of all, they are there with a lot of conditions. Third of all, the funding is largely biased towards the developed West. These are the reforms which we have been seeking in multilateral institutions, and in this year's G20 summit, we picked up this topic intensively. Then contributions from governments in India. Government of India, 20% of the funding is done by Government of India. From Government of Delhi, 3.22%. Government of Uttar Pradesh, 16.78%. So these are the sources of funding in India's first regional rapid transit system. And with this, we have ended the first part of Yojana for the month of December 2023. I will be meeting you shortly now in the next video covering the next two topics, that is India's rising stature and Meri Mati Mera Desh, in the part 2 of Yojana. Till then, stay tuned. Go through this, go through the handouts, and most importantly, don't forget to read the original text of Yojana. After watching these videos, reading the original text of Yojana will definitely be very, very easy for you. So, this is it. I will be meeting you in the next video.